This video is on lessons 4 and 5, which is factoring completely and factor by grouping. So before we talk about what it means to factor completely, we're going to work backwards, where we're going to actually take something that is already factored and multiply it back out so that you can understand what it means to factor completely. So if there is a number out in front, such as an A, there is a 2 out in front of your two binomials. That means that 2 started off as a GCF, and they factored out a 2 from the trinomial, and then they factored the trinomial into 2 binomials. So if there's ever a number out in front of one of your binomials, it means it was a GCF that was factored out to begin with. So we're going to go in reverse, and we're going to multiply these all back out so you can see what the trinomial looked like before it was factored. Now, this is all multiplication, so you know order of multiplication does not matter. 2 times 3 is the same as 3 times 2. That's the commutative property. So you get to choose who do you want to multiply together first. I'm actually going to multiply the two binomials together first to keep the numbers smaller. If I multiply this 2 into the parentheses first, it's going to be bigger numbers, which is fine. They're not terribly large, but so I'm going to multiply the two binomials together first. So I use the double rainbow method. You're going to basically multiply x into everything in the back set of parentheses, and then the 4 into everything in the back set of parentheses. So x times x. So I'm going to keep this 2 out here because I didn't multiply him in yet. X times x is x squared, 7x, 4x, and 28. Then you're going to combine your like terms in the middle. You're always going to have two terms in the middle that have common variables that you can combine. So this is 11x plus 28. Now that I've multiplied my two binomials, I can multiply everything inside by 2. So that is 2x squared plus 22x plus 56. And this was the trinomial that they factored into this guy up here, an A, and you'll notice they started by pulling out a GCF of 2 first, because everything can be divided by 2. And 2 is the greatest number that all three numbers can be divided by. And then notice if you pull out a 2, this guy is much easier to factor because you can use the 1am method, and you'll end up getting x plus 4 times x plus 7. Okay, so let's move on and do a few more. Again, I'm going to multiply out the binomials first. So that's 2x times x and 2x times 3. So that would be 2x squared plus 6x. Then you have to do the negative 5. So that's negative 5x minus 15. Now multiply everything, or actually you should combine your like terms first just to make them a little, make it a little less crowded in here. So 6x minus 5x is just 1x. Now multiply everything by 5. So that would be 10x squared plus 5x minus 75. And this would be what the trinomial was before it was factored. So the GCF they pulled out was 5 from every term. Okay, I'm going to stop showing my little rainbow. I'm just going to do it in my head. You would get x squared. Oh, watch what's going to happen. You're going to get a positive 5x and then a negative 5x. So those are going to cancel each other out. So I'm not even going to write the x terms. But then you do still have to multiply the last numbers together. That's negative 25. Now I'm going to multiply everything inside by 3. So that's 3x squared minus 75. And the last one. Again, these are the same things. This was a perfect square, difference of two perfect squares, because it's the exact same parentheses except one is a plus and one is a minus. So you'll notice the first term isn't going to go away. That's 9x squared. But when you multiply the two middle terms together, you're going to get 6x and negative 6x. So they're going to go away, and then you'll get minus 4. Now multiply everything inside by 4x. Be careful, there's an x there. So that's actually 36x to the third minus 16x. So notice the GCF this time involved not only a number, but also a variable. You can factor out an x from each term. So now we're going to actually see what it means to factor completely. So So basically, to factor completely, it means you need to first check. So your step one is to check for a GCF. If there is one, factor it out. The reason you want to do that first is because then it makes your numbers a lot smaller to work with when you're factoring the trinomial. If you wait and do the GCF at the end, sometimes some weird stuff happens and you might be confused on how to factor it out of both factors, because remember, you're going to have two factors, you'll have two binomials. So I would just factor it out first. So check for GCF, factor it out if possible, then factor the trinomial into your two binomials. So factor into two binomials. Now, sometimes there isn't a GCF, so then you just move on to factoring. Okay, so letter A, look at all of your terms. You got three terms here. What can you factor out of each term? The biggest number you can factor out is 4, and there is no common factor in all three in terms of x's because the 40 doesn't have an x. So the biggest and only thing you can factor out is a 4. What is now left is x squared plus 3x minus 10. This is now much easier to factor in our head because we can use the 1a for add and multiply method. So this one's not too terribly difficult to do in your head. What are the factors of negative 10 that give you positive 3? Well, it's going to be a positive 5 and a negative 2. Those multiplied together will give you negative 10, and they will add to positive 3. So this is your final answer. Letter B, a GCF that I can factor out of each term. There's only 2 terms this time, so hopefully it's a perfect square when I'm done GCFing. I'm going to factor out a 6 from both terms, and it would be x squared minus 4. That is awesome news because look, this is now a difference of 2 perfect squares. So this factors to be x plus 2 times x minus 2. Don't forget to bring down your GCF. The 6 has to stay out in front. Remember, it's multiplication. Same thing here. The 4 had to stay out in front. Okay, the next one. There is a GCF. It is 2. What is left is x squared plus 10x plus 25. And again, I can now use 1am. Bring down the 2. Keep it there. It's going to factor. I want to find what multiplies to 25 and adds to 10. It is 2 positive 5s. And the last one, I'm going to factor out a 3 from both terms. I'm left with 25 minus x squared. This is a perfect square again. So the square root of 25 is 5. He has to go first since the 25 was first. And then the x was second, so he goes second. 1 gets a plus, 1 gets a minus. Okay, now the last 2 are kind of tricky because they're not going to be 1am. So we're going to have to split the middle and factor by grouping. But first, always start. I know it says do guess and check, but I showed you split the middle and factor by grouping. So use that. You still always want to start with checking for a GCF. The greatest common factor, always start by checking if the smallest number can divide into all 3, and it can't. 10 can't go into 55 or 105 evenly anyway, nicely, without a decimal. So I'm going to have to try something smaller than 10. 5 can factor into everything. So I'm left with 2x squared plus 11x minus 21. Now, I cannot do 1am because of this 2 out in front. And I did get the greatest common factor because if you look at what's left, 2, 11, and 21, there is no common factor between those 3. So I'm going to have to do split the middle. Remember to do split the middle. You multiply 2 times 21, or negative 21, that's negative 42. So I'm going to list all the ways to multiply to negative 42 to get 11. Obviously, you have 1 and 42, 2 and 21. So far, I could not get 11 if I added or subtracted those. 3 and 14, that's our winner. So I'm going to rewrite 11 using 3 and 14. So to get 11 with 3 and 14, I have to have a positive 14x and a negative 3x, and then the minus 21. Now I'm going to group. I'm going to group these 2 together and these 2 together. So the front 2 and the back 2. I'm still going to keep writing my 5, but he's kind of just hanging out outside. He's still there, but he's not really part of the factoring right now. So in the front, I can pull out a 2x, and I'm left with x plus 7. And in the back, notice, guys, there's a minus here. I want it to be x plus 7. And there's also a negative here. So when I factor out my GCF, I have to factor out a negative 3 so that it turns it into x plus 7. Remember, you want to get the exact same thing inside your parentheses. So now, this guy, I'll put like big parentheses around him, he factors to be the following. Remember, I'm going to carry the 5, keep it out in front. My first factor, I'll write the one that's the same in both parentheses. It's x plus 7. And then my second factor is the two GCFs put together. So that was 2x minus 3. And that's your final answer. That is factored completely. There are no GCFs in either parentheses, and I'm done. Okay, the next one, the GCF you're going to factor out, it can't be 12. 12 can't go into 15 or 57. So I have to think of another number that can go into 12 and all the other two. I'm going to pull out a 3. So what is left is 4x squared plus 19x minus 5. Now I can't use 1am, and that is the GCF because between those three that's left, there's no greatest common factor. So I'm going to multiply the 4 to the negative 5, so that's negative 20. So I'm going to think of all the ways to multiply the 20 that I can get 19 so I can split it up. Well, 20 and 1. Ding, ding, ding. So I'm going to rewrite this as 4x squared. To get positive 19, I need positive 20x and a negative 1x. And then the minus 5 stays the same. So all I did was rewrite 19 as 20 minus 1x. So now I can group the first two together and the last two together. And I'm going to pull out a GCF from each grouping. So again, the 3 is just hanging out front. So what I can pull out of the first pair is a 4x, and I'm left with x plus 5. Now I want to get x plus 5 in the other grouping when I pull out a GCF. Well, I'll notice that it already looks very similar to that, but it's negative x minus 5. So what I can do is pull out a negative 1. Then I'm left with a positive x and a positive 5. So now notice my two parentheses are the same. So that means my one factor is x plus 5 if I GCF that out. And then what's left are the two GCFs, which is 4x minus 1. And that's your final answer for that factoring of that trinomial. Okay, so always first start with pulling or factoring out a GCF. Always, 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 if possible. Sometimes there isn't one. And then factor the trinomial that's left by either using the perfect square if it's a binomial and they're both perfect squares, or if it's at 1am, you can use 1am, and if not, you have to do split the middle and factor by grouping, which takes us into the next lesson. The next lesson is factor by grouping, so this should actually be review. In fact, if you understood factor by grouping, you can probably stop this video because this is literally just factor by grouping. So in the first exercise, they kind of introduce why factor by grouping works. So factor by grouping is really just using the GCF method. So here in the first example, they already did the split the middle and they started the factor by grouping. They just want to show you why the ending step is what it is. Well, if you notice, you have two terms here. Okay, this is one whole term because it's multiplication. Separated by the addition sign, here's the second whole term. If you look at those two terms, you want to find the greatest common factor between them. Well, they both share a 2x plus 1. So if I factor out a 2x plus 1 from both terms, in the first term, I'm left with just the x out in front, and in the second term, I'm left with the plus 7 out in front. So that's why that last step in the factor by grouping, that's why we do what we do. We're actually GCFing. I know I just tell you, well, the parentheses should be the same, and that's your first factor, and then whatever's left is your second factor. Well, that's why, because you're actually GCFing the 2x plus 1 or whatever's in the parentheses out of both terms. So here's your first term, here's your second term. They both share an x minus 2, so I can factor that out. And what is left from the first term is 5x. What is left from the second term is negative 4. So like these x minus 2's go away because we pulled those out. We pulled that out from both terms out in front, and then what's left was the 5x and the minus 4. So now we're just going to do some more practice with factor by grouping. So again, if you think you got this down, you probably don't have to watch these unless you just want to fast forward to the end to get the right answers. Okay, so they already actually did the whole split the middle part. So we're going to factor both of these by grouping the first two together and the last two together. So I'm going to put my parentheses around the first two terms and then the last two terms. So you need to have 4 terms to do factor by grouping. That's why we have to do split the middle sometimes with trinomials. So in the first pair, the greatest common factor between those is x squared. What is left would be 3x plus 2. Now hopefully I get 3x plus 2 when I GCF the second pair, which I hopefully will. Let's just double check. Now notice I want a positive and a positive. Well, these are both negative. So that means when I take my GCF out, I have to take out a negative number. So between 18 and 27, the GCF is 9, and I'm going to actually pull out a negative 9. What is then left would be 3x plus 2 because I pulled out a negative. Well, notice these are now the same, so I'm going to GCF out a 3x plus 2. And what is left when you GCF out a 3x plus 2 from the first term is x squared, from the second term is minus 9. Now, it says completely factor, so you are not done because you should notice that this guy right here is a perfect square. It's a difference of 2 perfect squares, so I can keep going. This guy cannot be factored any further. There's no quadratic left in him. Oh, why did I write a squared? There is no quadratic left. It's just 3x plus 2, not 3x squared. But this guy has an x squared, so that means I can factor him again. He factors to be x plus 3 times x minus 3. So this time I actually had 3 factors, and the trick, what should have alerted me that we're going to have 3 factors, was that in the original problem, the biggest exponent was a cubed, which means there's going to be 3 factors sometimes, not all the time, but most times. There could only be 2, or sometimes even 1 if they're all the same. But most times, just like with a squared, there's usually 2 factors. With a cube, there would be 3 factors. With a 4th power, there would be 4 factors. Okay, so let's do the next one. We're going to group the first 2 together, the second 2 together, pull out some GCFs. So in the first guy, I can pull out a 9x squared, and I'm left with 2x plus 1, which means hopefully I get a 2x plus 1 in the second pair, and it's very close, but they're both negative. So I'm going to pull out a negative 1. Now I have 2x plus 1. So that means my first factor is the 2x plus 1, because I'm going to GCF that out. And what is left is 9x squared minus 1. Now again, we are not done factoring because this can be factored further. It's a difference of 2 perfect squares again. So the 2x plus 1 stays 2x plus 1, but this guy can break down into 3x plus 1 and 3x minus 1. So again, there were 3 factors this time, and this one was this answer. So you have to make sure you factor completely. All right, the next one, if I group the first 2, I'm going to have a GCF of just x squared, and then x cubed, I'm sorry, I didn't see that 3. X cubed, which leaves me x squared plus 4. Then in the second group, I can pull out a positive 2, and I'm left with x squared plus 4, which is good news because those are the same. Now I'm going to GCF out the x squared plus 4. And in parentheses, what's left is x cubed plus 2. Now you might be thinking, am I done? Can I factor it any further? You actually are done this time because while these are both perfect squares, there's not a subtraction between them. So you cannot use the difference of 2 perfect squares. You are done. Could you factor it using the quadratic formula? Sure, but it's going to be an ugly number, so I would leave it here. All right, last one. Group the first 2. Group the last 2. We can factor out a 5x squared, and we are left with x plus 2. So hopefully I get x plus 2 in the second group. I'm going to factor out a positive 20, and I would be left with x plus 2. So my first factor is what I'm going to GCF out, which is the x plus 2. Then I am left with 5x squared plus 20 for the other factor. Again, double check that you can't factor either any further. X plus 2 can't be factored any further. This guy is not, they're not perfect squares. There isn't even subtraction, so you're done. And it's not a trinomial either. So that is it for factor by grouping.